So here's my graph. We put in the numbers, right? For those we reference, if you went 2 and 8, you were in the negative 50s, negative 60, negative 51, positive 57. So that's just too much. Okay, we're going to look at your XY intercept really. Oh, wait, hold on. So your inflection point is the point where technically it's vertex. It's what you guys would consider H and K. And so what happens is that local maximum or minimum, you don't have it here. You'll see when we do other ones, you'll get another high and low like a roller coaster. Like you'll plateau and it looks like there's two separate parabolas built into the cubic. So here you don't have anything, but they do exist with cubics and polynomials of 2 and greater. I mean of 3 and greater, okay? All right, X and Y intercept. Okay, so you now need to start solving them algebraically. I know I've let you guys get away with your graphs, as long as you guys can see it. Okay, so look. How do you find a y-intercept? Usually it's in your table. This one's really easy. None of you guys have issues with it. You just throw in the 0, and I get, oh wait, I did the wrong one. You get negative 247 minus 5 plus 3. Yeah, okay. And so your y-intercept is negative 247. And so that's really easy to find. I'm not going to go down negative 247, but that's where this graph, the function, eventually crosses a y-axis. Yes? Okay. So this is at negative 247. All you do is substitute it. So that's what you would write here, right? Okay, to let y equal 0, it's algebra. So, guys, quiet. Okay, if I'm going to let y equal 0, y is 0, and now you need to isolate your x, and you should be able to do that. Okay, so what's my first step? I need to get x by itself. Minus 3. And so, hold on, I'll catch up. Okay, now what? Divide by 2, very good. Do you guys want the 1.5 or 3 halves?
3 halves.
3 halves? Okay. Okay, so remember like what we've covered in the past. You do your K first, then you do your A, then you're going to inverse the function. And so how do I inverse a cube? Huh? Not square root, cube root. So yeah, you're correct. So now if I want to undo this cube, right, the inverse operation to cubing is cube rooting. Yeah? Okay. So, cube, and I'll put a little 3 here. And by the way, just make sure on the calculator, students in the past, they haven't wrote the 3. I didn't dock them as long as the next step they did the number correctly. The number is correct. So, meaning, if you guys have, so where's cube root? Here, shift, and then it's this. See that little 3 there? Oh wait, what did it do? Shift here, okay? It's 3 halves, right? Okay, if you wanted to leave it as negative 3 halves, that's what you're writing, correct?
Correct.
Okay, but let me do it as a decimal just in case those of you that want a decimal. All right, okay, so that's the equivalent. But for those of you that didn't want the negative 3 halves and you would have preferred the negative 1.5, then go ahead and cube root negative 1.5. You'll get the exact same number. Okay, so if you don't like the fraction, then you don't have to put in the fraction. Okay. John, you can't do that. John, you gotta turn it off. You gotta turn it off. Yeah? Okay, so there's that. And then what do I write down here? Simple. Don't complicate it.
Positive 5. Negative 5.
X minus 5. This just comes out.
Oh. So just find X.
And now what do I do? Oh, I forgot you guys. Okay, yeah, so now what do you do?
Add 5 is X.
Yes. And so now what's 5? 3.86. And so look, if you look at your graph, that's what you guys should see here, 3.86, that's a 4. And so here's your x-intercept, that's your, right, and so that's why I always told you guys, for the x-intercepts, you guys could always look at your graph and kind of estimate it, but algebraically, and some of you do solve it algebraically on the quiz and test, so good job. You should be able to solve them this way, and you're going to have to start doing it this way because you guys will see what we move forward with. Yeah? Or I guess you don't need that, you need this. Yeah?
Yeah.
Okay, so if I flip, so that, all this goes here. I know, sorry, it's little. Okay, what is my domain, you guys? What's my domain? What's my range? And what's my range? There, are you guys listening? Because I hear a lot of talking. Cubic functions, no restrictions. Cubic functions, all reals, no restrictions. Yeah? So make sure you highlight it like no restrictions. They're always, always, always negative, positive, negative, positive. Okay, what's my end behavior? So you know there's no restrictions, you know these guys are going to infinities, right? Okay, so as x goes to negative infinity, so as x moves more to the left, what's happening with the function?
Going negative.
Negative infinity. Okay, as x goes to the right, it's going where?
Positive.
Perfect. And then you guys could do the bottom ones, yeah? Or did anyone solve this already?
Yeah.
What's negative 5?
Negative 1,997.
900 and what?
97.
And then what is 6?
5.
Oh, we did that one. Oh, duh. Okay. Thank you, guys. Okay, good?
Yeah.
All right, so I'll cut the video. And then give the exponential one a try. Tomorrow I'll talk about the horizontal asymptote, but at the bottom it says inverse functions. If exponential functions have a horizontal asymptote, the logs have a vertical asymptote. Yeah? Okay. I don't even know what time it is. Let me